Hello everyone, this is lesson 17, the chain rule. So we are using chain rule. This is one of the method of derivative. So we are using chain rule for composite function. So how it looks like a composite function? So we combine the two function is the composite function. So we have a f is composed of g. We read it this way. So read f is composed with g of x. All right. Okay. If we have more than basic function, so x is basic, x squared is basic, x cubed is basic, and so on, right? Square root of x is basic, x to the 1/3 is basic, this kind of things basic, right? Beyond the basic, we say the composite function. So more than one function is combined together, it's a composite function. Okay, now in that case, how do we derivative? So we have this rule, y equal to f of u, and then u equal to g of x, then y is a differentiable function of x, and we have g dy over dx equal to f prime of u times g prime of x, right? So this one I can express f prime of g of x and g prime of x is the same because we say that u equal to g of x, u is here, right? Okay, means that outer function first or outside the function first, we want to derivative outside the function, then inner function. We do derivative inner function, but we have to keep the inside with when we derivative outside the function, all right? Okay, equivalently, we have this notation too, dy over dx equal to, look, we add the du over the u, right? So that is kind of we simplify, then we have a dy over dx. All right. Okay, now once again, we have y equal to f of expression, then f prime of expression times expression derivative of expression, like that. Look, I like this one better. Y equal to f of inside, then when you derivative, f prime outside, and the inside, keep the inside, and the inside the prime. Okay, so let's do this one. Sum and power rules. Let's using sum and power rule. So sum and power rule, what this mean? We have 3x plus 1 times 3x plus 1. Okay, there will be, we can expand and multiply together. We can do that, right? Or we can use y equal to a plus b quantity squared. That's a squared plus 2ab plus b squared. So there will be a. This is a b. So we have y equal to 3x quantity squared plus 2 times a times b plus b squared. So that will be 9x squared plus 6x plus 1, right? Okay. I told you last time, always algebraic word easier than the derivative, right? So algebra, if we can do algebra first, let's do it, right? Then y prime, how do we derivative? We drop the power and then we keep the coefficient, drop the power and reduce by 1 for the power. And second term is a 6. So we get 18x plus 6. This is the answer. Okay, now chain rule. Outer first. Chain rule. Think. Outer. Then inner. Here, outside, inside, the same thing. Okay, outer is this one, right? So we drop the power, dy over dx. Drop the power. Reduce by 1. 2 minus 1, which is 1. We don't have to write down. Now, inner. So we want to derivative what's inside. Then let's multiply. So we have a 6x plus 2. Then derivative of 3x we get times 3, right? So we multiply again. So we have 18x plus 6. Do we get the same answer? Yes. So we have dy over dx. It's the same notation. We learned the last time, right? Okay, now let's practice more. Outer. Derivative outer, then inner. Derivative of inner. Outer. So we said f prime of x equal to 10, 3 minus 2x. And then reduce by 1 for the power. And then inner. Then we cannot multiply this one, right? So because there is a power exponent. And then we want to derivative. First term is 0. Second term is negative 2. Okay, now we can multiply with the number, right? So we will get negative 20, 3 minus 2x to the 9 power. Okay. Ooh. This is looks like that, right? Okay. We are using product rule. We have to recognize what kind of rule we have to apply. So product rule first. So product rule said that no, hold on 1 second. We are using chain rule, right? So I missaw that. Oh, I see. That's why they don't have a parenthesis, yeah? Oh my gosh. Crazy. So I looked P of Q there, right? So this is not parenthesis. I should not make, right? All right. So then this is the first term. This is the second term. Then we need a derivative term by term, right? This is the sum of a derivative, difference of a derivative, right? Okay, let's do derivative p prime of q, which is derivative of q, 13q, minus plus derivative respect to q of negative 4, 3q squared minus 1 to the 5th power. Okay, now we want the derivative of 13q, which is a 13. What about this one? So outer first, then inner. Oh, inner, right? I said inter earlier. No one was telling me. Inner, inside. Okay, now outer is 5, but then we keep the coefficient, so negative 4 times 5, 3q squared minus 1, and reduced by 1. So it's a fourth power. Now we have to use a chain rule, that is derivative, derivative respect to q, 3q squared minus 1, that's inside, right? Oh, sorry about that. Okay, now we have a 13 minus 1, 20, minus 20. And then we have a 3q squared minus 1 to the fourth power. Okay, now derivative of 3q to the second power. Once again, we drop the power, we get the coefficient, it's 6q, right? So that is 3 times 2q, right? Okay, so then 13, 6 times 20, which is 120, and q there, and 3q squared minus 1 to the fourth power. Okay, now little bit advanced. In order to use power, we have to use like a power, right? So 6, 4x to the third power plus 1 to the negative 5. Once again, outer, then inner. So outer is this, g prime of x, 6, we keep the coefficient, drop the power, and reduce by 1. So negative 6. Then what's inside? 4x to the third power plus 1. So there will be negative 30, 4x to the third plus 1 to the negative 6. And then we want to derivative with respect to x. We keep the coefficient, drop the power, reduce by 1. So we have a second power. Okay, so altogether 4 times 3, which is 12. 12 times 3, 360. So negative 306. Oh. Negative 360 for x to x squared there, right? X squared. And for x to the third power plus 1 to the negative 6. If we want to write down positive power from the negative, we can rewrite this one like this, right? Okay, now in order to use power, we convert to as power. So this is 1/2 power. Then outer prime. Then inner prime, right? Okay, outer is 1/2. Y prime, 1/2. 3x squared plus 4x. plus 9 minus 1. So we have minus 1 means 2 over 2 in that case. And then what's the inner 3x squared plus 4x plus 9, right? Okay, now 1/2 3x squared plus 4x plus 9 and negative 1/2. And then we want to derivative what's inside. So keep the coefficient, drop the power, reduce by 1. And second term, just a 4. Okay. This one we have 6. And let's do one more time. Let's just simplify. 1/2 6x plus 4. We can simplify this one, right? 2 goes to 6 3 times. 2 goes to 2. 2 goes to 2. 2 goes to 4 twice, yeah? Or you can factor out, right? So 2 times 3x plus 2, right? So more easier way. So we have 3x plus 2. So let's put the 3x plus 2. And once again, negative power, we can express as a positive over 3x squared plus 4x plus 9 to the 1/2. But 1/2 we can express as a radical. So 3x plus 2 over square root of 3x squared plus 4x plus 9. Okay, practice more. Look, this is a coefficient with the recognize. This is a coefficient. And we can express this as a power, right? Then outer prime, then inner. Okay, so y prime, which is, we keep the coefficient, drop the power, and reduce by 1. Once again, 1/2. 1 in the case, negative 2 over 2. And chain rule, what's the inside? 3 minus x squared. Okay, then we get, look, 2 goes to 4 twice. We had the experience earlier, right? So we have a 2 over 5. 3 minus x squared, negative 1/2. Then derivative of this was inside. So we get, first term is 0. Second term is negative. Drop the power, reduce by 1. So we have 1, right? So then we get negative 4x over 5. Three minus x squared, negative 1/2. Well, negative 1/2. We can express as a positive power. So look, 3 minus x squared to the 1/2 power. Yeah. Okay, 1/2 we can express as a radical square root. So negative 4x over 5 square root of 3 minus x squared. Okay. All right, let's do this one. we practice enough, right? Now we can do this one. The revenue in dollars from sale of X items of a product is R over X dot. First one, find the marginal revenue when 40 items are sold. So we did it yesterday, right? What is marginal revenue, right? So marginal revenue, we denote bar with the MR, right? The first letter M and first letter R from the revenue. Okay, marginal revenue, then R prime of X, right? So we want to derivative from revenue function. So what do you get? Oh, let me see. So let me get this one. Okay, so we want to derivative first term, then 15, we drop the power, and 3x plus 1, excuse me. Now, reduce by 1, so negative 2, right? And second term, we want to derivative, then keep the coefficient, then drop the power is 1, reduce by 1, x to the 0 power, which is 1, right? So it's just 50. Last term is 0. Okay. Then we have a negative 15 and negative power. So we have 3x plus 1 to the second power in the denominator and plus 50, right? Okay, we want to find out the 40 items are sold, right? So marginal revenue, 40 equal to R prime of 40. We have negative 15 over 3, 40 plus 1 to the square plus 50. Okay, so then we get this one, $49.99.69. Then since we talk about the money, so we can say that this is $50 per item. Okay, so second part, if the sales go from 40 items sold to 41 items sold, revenue will, we have a positive, right? $50, so increase by about $50. Okay, all right. More. Okay, so at the point for the function, find the following. We have a function. All right. So find the slope of a tangent. So with the derivative, we can find instantaneous rate of change and then slope of tangent line or the instantaneous speed, right? Same as instantaneous rate of change. Okay, we learned for derivative, right? We need to find marginal revenue, also marginal profit, also, which one I'm missing? Marginal revenue, profit. marginal cost, right? Okay, now we're going back to find slope of tangent line. Line tangent, slope tangent, slope of tangent line. Okay, all right. So find the derivative means find the derivative. Okay, so we want the derivative. We change it to the power, right? So we want the derivative. Then outer first, prime, then inner prime. So outer is the 1/2. Last, and then reduce by 1. So that will be 1/2 minus 2/2. And then what's inside? We want to derivative, right? Okay, so there will be 1/2 x to the third power negative 1/2. Now, what's the derivative of this one? Drop the power, reduce by 1. So 3x, then second power, and then the 1 is we do derivative, we get 0, right? All right, now we have 3/2 x squared and negative power. So we denote it this way, x squared. And we have the experience, let's denote like a radical, x cubed plus 1, yeah? Okay, now we want to know about the slope at the point 2, 3, right? So at 2, 3. So there will be dy over dx, 2, 3. We knew this is a x, this is y. But then we don't have a y in that case, right? So we have a 3, 2 squared over 2 x to the third power, 2 to the third power plus 1. Okay, so there will be 12 over 2 square root of 9. So 12 over 2 square root of 9, which is a 3, right? So, oh, this is 6, yeah, which is 2. We don't, that's more easier way than simplify. Okay. So they say that find this. Okay, let me clarify. The slope is 2, right? This is a slope. And they say that find the instantaneous rate of change of the function at the given value. So we also say that this is 2 because it's the same. This is the same, right? This is the same. Same. Same as y prime, same as derivative, right? Okay, let me quickly draw. So this means we have a function. So it looks like this. And then at 2 and 3, right? This is 3. At this point, we want to know about the slope. This slope is the 2, which is same as instantaneous rate of change. Make sense? All right. So last question. So if the demand of Q units of product price, dollar per unit, is described by the equation right here, find rate of change P, right? So we know how to find derivative. Okay, in order to do that, we must change it to power, right? So power, so 400 2q plus 1 to the negative 1/2 power. Then we are using chain rule. Outer derivative outer, then derivative inner, right? Okay, now let's do it. So we want to derivative. We keep the coefficient, drop the power, reduce by 1. That 1 in the case 2/2. Then what's the inside? Derivative with respect to Q. So there will be 2 goes 400, 200, right? So we have negative 200, 2q plus 1, negative 3/2. We want to derivative of this one. First term is 2, right? And the second term is 0. Okay, then negative 400 and the negative power over 2q plus 1, 3/2, right? Okay, now let's express as a rational, radical expression, right? So this will be root and then the 3 will be exponent, right? So that means negative 400 over root square means square, right? So we have 2q plus 1 to the third exponent, right? Okay, in general, we don't use 2 as index, right? We call it as index. We start with a 3, which is a cube root, right? Square root, normally we don't write down, okay? All right, so this is the answer. So we can write down the answer, this one, copy, here. Can I see? All right. So we're done. Thank you for watching. Bye.